Hey Geometries, this is Mr. Bloom, and this is lesson 6.4. Oops, and this is lesson 6.4. Let's get rid of that. That was kind of an interesting deal. Got that. Okay, this is lesson 6.4. Properties of rhombi, rectangles, and squares. Oh my. Okay, students will be able to define and classify special types of parallelograms. Wonder what these special types of parallelograms might be. Oh, rhombus, rectangles, and squares. Okay, rhombi, by the way, is plural for rhombus. Use properties of diagonals of rhombuses and or rhombi and rectangles. Okay, so that's where we're going. So key concepts, special parallelograms. Okay, a rhombus is a parallelogram with four congruent sides. So if it's got four congruent sides, it can be classified as a rhombus. A rectangle is a parallelogram with four right angles. If it has four right angles, it can be classified as a rectangle. A square is a parallelogram with four congruent sides and four right angles. Well, if I have four congruent sides and four right angles, remember it has to have both, then I can call it a square. So really, when you look at this, a square can be classified as a rectangle, and a square can be classified as a rhombus. So when we look at this as a Venn diagram, and we have a Venn diagram at the right, shows the relationship about special parallelograms. All rhombuses are here. All rectangles are here. Okay, and because all rectangles and all rhombuses are together here, we got to get this going. Because of that, we know that the squares are in both. Remember, some rectangles are squares, some rhombuses are squares, and squares can be classified as both a rhombus and a rectangle. So now, with that idea, decide whether the statements always, sometimes, or never true. Okay, a rhombus is a rectangle. Okay, well, a rhombus is a rectangle. We have overlap in the rectangle, so yes, sometimes. Okay, sometimes that's true. So sometimes that's true. A parallelogram is a rectangle. A parallelogram is a rectangle. Well, if I talk about a parallelogram, special parallelograms, okay, a parallelogram is a rectangle. Now, right now I know all rectangles are parallelograms. Okay, let me bring that down so I stop clicking on that. All rectangles are parallelograms, but not all parallelograms are rectangles. So sometimes that's true. A rectangle is a square. A rectangle is a square. Sometimes rectangles are squares. A square is a rectangle. A square is a rectangle. Well, all squares can be classified as rectangles, so that is always true. Okay, a rhombus is a square. Not all rhombuses have right angles, so a rhombus is a square when it has right angles, so sometimes. Okay, and that's us using the Venn diagram to answer those. Now in this next one, if a parallelogram is a rhombus, if ABC is a rhombus, if a parallelogram is a rhombus, then its diagonals are perpendicular. Then when I draw diagonals, I got a right angle. This is important. Diagonals are perpendicular in a rhombus. Oh, that's kind of nice to know. Now, when I do have a rhombus, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Oh, the diagonals are angle bisectors. So angle 1 and 2 are the same, angle 3 and 4 are the same, 5 and 6 are the same, and 7 and 8. But more importantly, the red angles are the same, the blue angles happen to be the same, because remember, the rhombus has these properties, but it also has all the properties of a parallelogram because it's a parallelogram. So diagonals bisect each other, opposite sides are the same, opposite angles are congruent, diagonals bisect each other, and one set of sides is, so it's going to be great. Those things all come into play. Now, let's move on here. Trying to get that going. Finding angle measures. What are the measures of the numbered angles in the rhombus ABCD based on what we already know? Okay, turn it off, reread your notes, and come up with a solution. Okay, now we know that angle 1, the measure of angle 1, must be 90 degrees. Okay, because all rhombuses have diagonals that are perpendicular to each other. Okay, the measure of angle 2, the measure of angle 3, and the measure of angle 4. Those are next. Now let's talk about the measure of angle 2 and 3. Remember, rhombus's diagonals bisect the angle it comes to. So this is also 58 degrees. And rhombuses have all the properties of parallelograms. So opposite angles are the same measure. So these must both be 58. So we have 58 degrees. Okay, and now because this is a right triangle, I know them, and this is going to be supplementary. I shouldn't say supplementary. This is going to add up to 180 degrees. Angle 4 plus the measure of angle 3 plus the angle 1. And because it's a right triangle, the measure of angle 4 plus 58 degrees must equal 90. I know that that's true. Okay. And here's the thing. If I back that up and said, hey, 58 plus should say 90, excuse me, 90 plus the measure of angle 4 plus 58 is equal to 180. If I just subtract the 90, that's where I'm getting this next relationship. So I know that this has got to be 32. The measure of angle 4 must therefore be 32 degrees. So that's 32. Okay, so now it's your turn. Again, go for it. Get those done. Think about what it is. Shut it off and try to do it on your own. Okay, welcome back. Now, I know that this is 104 because this is a parallelogram as well, but I know these are true, and these are true, and these are true. Isn't this an isosceles triangle? So I know that the angles that are left must be the same. Angle 1 and angle 3 must be the same. I know that from isosceles triangle. I also know that from properties of rhombus. Okay, so if I take 104 degrees, okay, plus the measure of angle 1 plus the measure of angle 3. This is 180 degrees. 104 is measure of angle 1 plus the measure of angle 3 is equal to 76. Now, if I keep in mind that 1 and 3 are equal, I just say, hey, well, I got two measures of, say, angle 1 equals 76. I divide, the measure of angle 1 is 38. Well, the measure of angle 1 is 38. The measure of angle 3 is 38. The measure of angle 2 is 38, and the measure of angle 4 is 38. All those are the same. Now, in Theorem 615, if a parallelogram is a rectangle, then its diagonals are congruent. If ABC is a rectangle, its diagonals are the same. Now, this is true in a square as well, but not in a rhombus. Okay, so now, multiple choice. In rectangle RSBF, SF, this whole thing is 2x plus 15. Okay, RB, they're saying RB is 5x minus 12. Okay, so now if I know RB is 5x minus 12, and I know that SF is 2x plus 15, I know if they're equal based on the property I just read. So now I can solve. So 15 is equal to 3x minus 12. And I add 12, 27 is equal to 3x. Now I know x is 9. But they ask, what is the length of the diagonal? Hey, look, the first wrong answer. Okay, so it's 9. So 2 times 9 is 18 plus 15 is 33. Let's double check my work and go, well, 5 times 9 is 45 minus 12, excuse me, minus 12, I was going to write what it equaled to, minus 12 is equal to 33. Now, those are 33. Well, it's D. Okay, careful. First, wrong answer. Okay, read the question. Make sure you double read. Okay, now, it's your turn. Give it a try. Read the question and answer the question. Okay, welcome back. If ln is equal to, and I've got ln the whole deal, ln is 4x minus 17, and mo is equal to 2x. I've got mo is equal to 2x plus 13. Okay, What are the lengths of the diagonals of rectangle LMNO? Now, I already know now this is rectangle. They told me. So now those things are equal, and for sure, this is right, my setup. 2x minus 17 is equal to 13, 2x is equal to 30, and x is 15. Now, keep in mind, I found x, and they asked me to find the length of the diagonals. So my length of my diagonals for my LN is going to be 4 times 13, 15, minus 17. So that's 45 minus 17. Excuse me, not 45. Should be 60 minus 17. Let's make that better. 15 minus 17, and that should be 60 minus 17, which would give me 43. Now, I get to double check my work, remember, because MO is equal to 2 times 15 plus 13, and that is going to be 43. So the lengths of my diagonals are both 43. Now, reasoning, what type of triangle is triangle PMN? So this is kind of an extra little deal. I've got triangle PMN. Well, this triangle, these are all the same. So PMN has to be an isosceles triangle. So triangle PMN is isosceles. Okay, now, I don't know anything else about that triangle. I don't know anything about what the angle is yet. We will be able to figure that out eventually, but not now. Now, is each parallelogram a rhombus, rectangle, or square? Explain. Well, I see this first one here. I've got my sides are all the same. Okay, all sides are congruent. All right, so therefore, if also, and I do not have 90-degree angles, so it must be a rhombus. Okay, and because there's no right angles. So keep that in mind. In this next one, I know this is a parallelogram. Please notice that these are parallelograms. People are like, well, why are you doing that to them? This is the same and this is the same. Because they're parallelograms though, opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. So we got opposite angles are congruent. Okay, opposite sides are congruent. It's got to be a square. Consecutive angles are supplementary. Okay, that's where we're going. So that's where I'm getting all those properties. Now, in the diagram below, PQRS is a rhombus. What's the value of Y? Go. Remember, turn me off. I got some people, well, their opposites aren't the same. Folks, I didn't tell you it was a parallelogram. I said it was a rhombus, and rhombuses have all the same length side. So therefore, 2y plus 3 is equal to 5y minus 6, and now I solve for y. Okay, so 3 is 3y minus 6, and I add, 9 is equal to 3y, so y is 3. Oh, cool, so y is 3. That's 6 plus 3 is 9. 15 minus 6 is 9, so I've got 9999. What's the value of y? I found the value of y, I checked my work, and I'm all happy, and I'm moving on. Hey, look, it's summary time. Summary. Objective. Students will be able to define and classify special types of parallelograms. Use the properties of diagonals, of rhombuses, and rectangles. Now, special types of parallelograms. If it's a rhombus, all the sides are the same. If it's a rhombus, diagonals bisect each other. If it's a rhombus, keep in mind, I shouldn't say if it's a rhombus, all three of these are parallelograms. So all the properties of parallelograms fall into place. All of them have opposite sides are congruent. Consecutive angles are supplementary. Opposite angles are congruent. Diagonals bisect each other. So keep that in mind. If it's a rectangle, all the angles are right angles and diagonals are the same. If it's a square, it has all the properties of rhombus and rectangle. If it's a square, all the sides are the same. All the angles are right angles. Diagonals bisect each other and are perpendicular to each other. Okay, so keep that in mind. I hope things are going well. If you've got questions, please locate your local geometry teacher and ask them the question. Again, make sure you're checking out your quad flow chart. In our quad flow chart, we have these things all checked off, along with rectangle properties, rhombus properties, and properties of squares. So those things should be filled out because this chart is your note card for the test, okay? And again, check off the things you know so far and start wondering, gosh, what things will be left? Because we're halfway through the chapter. Have yourselves a great day.